Hey, you there. Have you ever struggled with word problems in chemistry?
Well, today we will be walking through one of the more difficult problems in the acids and bases unit of Chemistry 12. This video will offer you a step-by-step explanation of the work we are doing and explain why we must take these steps to reach our answer.
My name is Matthias.
And I'm Razan, and the example question we'll be solving is found on page 143 in the Hebden Chemistry 12 workbook.
Here's the question we will be explaining. A chemist has a 2 liter of a 0.00120 molarity KOH solution. What mass of HCl would have to be added to the KOH solution to produce a solution having a pH of 10.875? To start, we must find the molarity of hydroxide in the original solution. To do this, we write out the dissociation equation of potassium hydroxide, which is KOH turns into K plus OH ions. Because potassium is a spectator ion, we can just ignore it. Because we see that KOH and OH minus have the same coefficient, 1, then we know that the concentration of KOH and OH minus are the same, which is 0.00120 molarity.
Now, let's simplify this pH value here. We are working with a basic solution, meaning that we have excess hydroxide, so we want to find our pOH so we can calculate the concentration of excess hydroxide. pH and pOH add up to 14 at room temperature, which we can assume is the temperature present. So our pOH is just 14 minus our pH value of 10.875, giving us 3.125. Because hydroxide is an excess, we know that the concentration of hydroxide excess is equal to the concentration of hydroxide given minus the concentration of hydronium given.
Our concentration of hydroxide given is 0.00120. To find our concentration of hydroxide in excess, we need to reference our pOH value of 3.125. To find our concentration of hydroxide, we need to take the antilog of the negative value of our pOH, basically just the inverse calculation of negative log, which is what the p means. If we take the antilog of negative 3.125, we are given 7.50 times 10 to the power of negative 4 molarity, which is our concentration of excess hydroxide. Now we can solve the concentration of hydronium.
To solve for concentration of hydronium, we just use our equation. Concentration of hydroxide excess is equal to concentration of hydroxide given minus concentration of hydronium given. This can be rearranged to concentration of hydronium given is equal to concentration of hydroxide given minus concentration of hydroxide excess. This gives us the equation, concentration of hydronium given is 1.20 times 10 to the negative 3 molar minus 7.50 times 10 to the negative 4 molar, which gives us 0.00045 molar. This means that our concentration of hydronium is 0.00045 molar. We are asked what mass of HCl is added, and we know that because HCl is a strong acid and it neutralizes completely, that the concentration of hydronium is equal to the concentration of HCl, being 0.00045 molar.
Now we calculate the mass of hydrogen chloride. First, we need to find HCl's molar mass. Hydrogen's molar mass is 1.0 grams, and chlorine's molar mass is 35.5 grams, giving us a total molar mass of 36.5 grams for HCl. Now we state that concentration is equal to moles over volume, so therefore 0.0045 moles over 1 liter times 2 liters, because there are 2 liters of the solution mentioned in the question, times 36.5 grams of HCl over 1 mole of HCl, and should give us the total grams of HCl. In the end, our final answer is 0.03285 grams, which is then rounded to 0.033 grams of HCl.
Created using Powtoon.